And we are live. Today, we're going to discuss the practical challenges associated with Retrieval Augmented Generation, or RAG, one of the most popular generative AI projects. I'm Kevin DeWalt of ProLego, and I'm joined by Justin, Ben, and Cam, three of our engineers with experience building RAG applications. I found that RAG is easier to understand with an example, and I'm going to show you how to do one in ChatGPT. So I apologize for the bit of the pausing there. We had some echo coming back due to my poor setup of the YouTube Live, which I've now now fixed by closing another window. So let me start that again. I found that RAG is easier to understand with an example, and I'm going to show you one in ChatGPT. So let's jump into that. Let's suppose that I'm an employee working at ProLego, and I want to know whether I'm allowed to bring my dog, Charlie, here to work. So I can ask ChatGPT a question like, can I bring my small dog Charlie to work? And actually, I'll start at the top here. Can I bring my small dog Charlie to work? And when you ask this kind of question in ChatGPT, it has no context. And so it gives me some generic answer about HR policies that is like a lot of words that say effectively maybe. But now imagine that I ask the same question, but I first retrieve the workplace policies from ProLego's policies, and I actually cut and paste those into the prompt window. So with the benefit of this extra information and a little bit of extra instructions, ChatGPT can now generate a more accurate answer to my questions and say things like, because of this particular workplace policy, if Charlie weighs less than 30 pounds and he's not going to attack people, you can bring him into work, along with some disclaimers. So now ChatGPT can generate a useful response because it's augmented by our actual data. So the generated response is augmented by the data I retrieved. Retrieval Augmented Generation, hence the name RAG. Since I do not want to be cutting and pasting text into ChatGPT, we want to find a way to do this automatically with an application, which I have shown here. So I'm going to do a quick walkthrough of this application, then I'll keep it up on the screen so we can refer to it during the video. All right, so let's say we begin with thousands of pages of employee policy documents in emails, wikis, PDFs, basically whatever we have. We then split them into chunks of text, and then we use an embedding LLM to convert them into embeddings. Embeddings are basically vectors of numbers. And we also then pass the question or query that I'm asking, like, can I bring Charlie to work, through the same model and also generate the same vector of embeddings. So embeddings are great because they allow you to find text that is most similar in meaning using mathematical techniques. So in the particular example I showed earlier, my question about pets would be converted to an embedding. And then we would find an embedding in similar meaning that discusses pets and workplace policies. We'd find the ones that are most similar, take those embeddings, convert them back to text, and send them into the prompt, just as I showed you with ChatGPT, and it generates the response. So RAG is one of the easiest ways to customize a general purpose large language model like GPT-4 with your data. And that's why it is one of the three most common initial use cases at almost every company we talk to. We built a working example that I covered in episode 1 of our Generative AI strategy series, and we'll include a link to that down in the show notes. All right, with some of that background out of the way, let's get into some specific questions about this. All right, so Justin, Cam, and Ben. Let me kick this off with kind of a generic question that a lot of people might be experiencing. So when I look on YouTube and the internet, there is a bazillion, get started with RAG articles that are usually based on large blocks of unstructured text documents like blog posts. And the person puts together a well-worded example showing how you go through all these steps and you can do document Q&A. So when you see these type of example, I guess sort of textbook projects, how are the problems that you find working on real projects with our clients different from these examples? Who wants to go first?
I can go first. The first thing that comes to mind for me is those chunks up there. How do you get the chunks so that those text chunks are meaningful? And so, for example, we often see things like policies, procedures, regulations, and these documents have a lot of structure. So there'll be sections and there'll be subsections or subsections. And the context for those chunks is sometimes spread around. So you might have a super section that says, well, here's the rule A, B, and C, and this always applies except for the following conditions. And then you have A, B, C, D, E, F. And so if you just naively chunk that into, say, sentences or even paragraphs or even subsections, you may be missing something that's important. And so that's maybe a long way to answer is the first challenge that we typically have to overcome is how we parse the documents and parse them in a way that retains important document structure so that we have all of the relevant context in the chunks when we need it.
So when I look at this diagram, it sounds like what you're telling me is I first see this and I think the complex stuff is the stuff here at the bottom, right? And you're telling me the biggest challenge is actually the thing that looks like it would be the easiest, and it would just be downloading a Python script. It's taking the documents and extracting all the structure and putting it into chunks in a way that retains the structure. Is that correct?
Yeah, I think that's correct. Now, the embedding LLM, that's all complicated, but it's also pre-trained models, and so we don't really have to worry about it. So when we go into a real project, the first thing that we need to, quote, worry about or consider is how do we get the text? How do we get the data and get it in the right format? So, yeah, I mean, in a lot of ways, maybe it's like normal data science. The first thing you do is you get your data, you do exploratory data analysis, you make sure you have good data going in to whatever model it is so that you have good results on the backside.
Okay, so I guess then chunking and processing data is the first challenge that a lot of these projects don't really mention. Anything else, Camera Ben, you want to point out?
I have something to add to that. A lot of these projects just show documents as the source of information, but in a real client project, it might not just be a document. There could be PDFs, Word docs, SharePoint websites, PowerPoint slides. Like there's a number of different things that all of this stuff could be represented in. And so it's not as simple as copying and pasting a text document with a simple structure and popping it in.
Are you saying that real data is messy? Is that what you're going at? You're this crazy notion?
A little bit, just a little bit, yeah.
Not to mention things like tables, which I know you spend a lot of time with, Cam.
Right.
Yeah.
Tables can be tricky.
Let me just, maybe this may not be obvious to everybody. So I think Justin, you mentioned document hierarchy. Like, why is that important? Like, why do I have to maintain document hierarchy? Like, so what? Why can't I just like flatten the whole thing? It's just going to find meaning, right? Meaning's meaning, isn't it?
In some cases, maybe you can get away with ignoring the hierarchy, but in other cases, there's important context that is conveyed through the hierarchy. So if you have a super section, like I mentioned a few minutes ago, said, well, this rule always applies except in these conditions. And then you have a list of conditions. Well, if you just look independently at each condition, you don't know that it's an exclusion to a rule because that statement that this is an exclusion appeared somewhere else in the hierarchy, and it covers a list of subsections underneath that statement.
Yeah, I think it's, I guess another example of some of the stuff we had encountered in, in like life insurance or other areas where you might get an attending physician statement or some, electronic health record. And if the record says like, patient does not have cancer, diabetes, heart disease, like that, obviously missing that does not have, that's a game breaking detail that you can't leave out.
Yeah, it's a good example.
Okay. So, then like what are some of the common techniques for like parsing documents? Are these just generic libraries that I got to go, search on Stack Overflow for the right one and download it? Like how does this actually work in practice?
I can talk about this a little bit. So I think in general, you're going to use probably different libraries depending on what type of file you're parsing. Maybe for a pure text, plain text document, there isn't really any special library that you need to do for a PDF. Maybe it's something more complicated or Excel spreadsheet or something. But in general, you're just trying to parse this file type, whatever it is, into some kind of data structure that preserves the meaning that you want to preserve in the document. And then also come up with a file structure that's easy to do your operations on, like get it into a nice sort of list-based form that you can calculate embeddings on or run through these ML models. So that's kind of the main technique is using the library and getting this document into a data structure that's in the form that you want to work with while still preserving the meaning.
And in practice, like, what is your workflow when this happens? Like how does this actually work in practice? If you're going to plan a project, what would you expect out?
Sure. So like just for an example, like say you have a whole bunch of PDFs you want to parse. You can plan on spending a couple of days, maybe, just getting the library up and running with some example PDFs, writing some heuristics as far as, capturing different parts of the document. Like usually with PDFs, your parser will give you basically a list of all the elements on a particular page. So you'll get like lists of lines of text or lists of tables or whatever. And then you end up kind of sorting them by position and looking at fonts or colors or whatever to try to identify headings in the structure. And you can, spend a few days kind of just building out code that can capture that information and use heuristics to put that into a meaningful structure.
Excellent. Any more comments on that, or should I jump into the next question?
I think just one more comment is usually you want to have some kind of flat representation. So even if your document is a hierarchy, machine learning models and kind of want these flat data sets, or you want to be able to process things in batch. So usually we end up trying to get something into a form where you have like a list of elements, and then the hierarchy is represented by some kind of key or other data structure that's attached to each one. So we'll often have like either a list or like a flat dictionary where the key or a part of that element represents the section, like or the hierarchy in the document, and it also serves as a unique ID. So maybe your key is like the original file name, and then the chapter name, and then the subsection name, and then the paragraph name, or something like that.
Okay, I guess I usually end up thinking that the structure is being in some kind of JSON file. You say you take like the JSON file and that becomes your keys, the dictionary, different headings and stuff. Is it?
Kind of, yeah. I mean, you could basically you want to parse a data structure that you could easily convert to a JSON file. And it would be kind of flat, not something that's deeply nested, but is sort of flat and limited in its hierarchy.
I got it. So like a JSON file can be almost unlimited. It's in a hierarchy. You keep throwing curly braces on until your screen's full of nothing but curly braces. You got to flatten that out so you have like clear levels to it. Okay.
Yep. But then still having the information in there that sort of can let you map things back into the original hierarchy.
It sounds like data science. Okay, let me jump ahead to the next question here. So like, what are some of the other potential complexities when it comes down to this, retrieval section? So let me I guess I'll just jump back here into the diagram here. It's like when it comes back into, this, either the most similar retrieving the right type of embedding, like what are some of the complexities in there? I think I gave a pretty trivial example of a pet policy. Seems like, probably not that many layers of an employee policy that deal with bringing dogs to work. So finding that is probably pretty easy, but you can imagine a lot more complexity in the retrieval process. Anyway, what are those things that you kind of encounter?
I think there's a couple of things. Some of this revolves around context size, and context size is relevant here in two cases. One is the embedding model.
Just to I'll put that out for the people not right. You're talking about the context size, I mean the length of the context window of the LLM, or how much data it can process, correct?
That's true. Well, that's one aspect of it.
Okay.
So one aspect of it is the
good thing I asked. Apparently, I don't understand it either. Okay.
So that aspect of it is the context size of the generative LLM. So in other words, we can't, if we have 1,000 documents, we can't take all 1,000 documents and give them to the LLM. That's why we have to do this similarity search, where we're trying to find the most relevant pieces of information for the LLM. And so to that end, because we can't shove everything into the LLM, we need to do this embedding search, this similarity search, this relevance search, all different ways of saying the same thing, and decide what's the most relevant, and only send the most relevant pieces of information to the LLM. So in your example with the pet policy, we would want to search through all the company's policies, but then only select the policies that look like they're relevant to, bringing a pet into the office, and make sure we get the ones that are relevant, but we don't overload it and have a lot of extraneous or irrelevant information going into the LLM.
Okay, and when you say like most relevant, again, that comes back to like data science and product design and user feedback. I mean, that's application specific. Is that?
Yeah, I think it's application specific for sure.
Yet another example of why we won't be replacing data scientists and programmers with AI anytime in my lifetime. Definitely my career, on my lifetime. All right. Anybody else want to talk about retrieval, or I'll jump into the next question on like more general challenges?
Well, I was going to say one more thing, and this is kind of related to context, but not in the LLM. So when we generate embeddings, over what size of text can we or should we generate those embeddings? So if we take really small pieces of text each sentence, we generate an embedding for it, well, we're probably going to miss some context if we go sentence by sentence. And so those embeddings aren't going to be very useful. On the other extreme, if we try to embed an entire document, well, it's kind of too much information that we're trying to squeeze into this small representation of the embedding. So our retrieval step is not going to be very good. And so I think there's a sweet spot that requires some finesse and some tricks sometimes to get the right amount of context in the chunks up top, so that when we embed them, the embedding represents a useful and a meaningful piece of text. It's not too narrow and it's not too broad. And that allows us to effectively search over what's in the documents.
Okay. So, every time we get into one of these things, I start realizing how little I actually do know about what you guys do. But so then the chunks, I'm assuming that I think of this in my mind as like, we've got a document that's a page long. We got 4 sentences. We got 4 chunks, but the chunks could overlap potentially. Is that the windows could overlap, and that way you get the benefit of not missing and you get the wider context? Is that?
Yeah, and that's one of the tricks, or one of the things that we'll experiment with, is what chunk size is adequate for a certain set of documents. It's probably not a single sentence, so maybe it's a paragraph. But to your point, maybe there needs to be a sliding window, or a window that gets a subsection plus the text from the supersection, just to make sure that we get all the right context in the embedding, so we can effectively search over them.
Okay. And I imagine there's a performance trade-off with how big you make these in terms of the complexity of the lookup. I could chunk every character all the way through, but that feels like a pretty big lookup table.
And not a very useful table, because if you have embeddings that are embedding the letter A, you're very good a search index.
Right. Okay. Yeah. All right. Excellent explanation here. All right. I'll jump to the next one. So what is the most important thing to get right for like a RAG application? Like if you're looking at where you're going to invest your time, where is it? Is it in the generative part? Like, is it pick, like I get this question a lot from people who ask, well, what's the best embedding model? Like, where do you want to invest your time?
I'm happy to go.
I would say,
let somebody else.
I can go for it.
Okay.
Yeah, I would say the retrieval step is the most important part. If you get this wrong, then the text generation step is going to be based on incorrect information. If you're asking like a factual based question and your retrieval step gets an older document with outdated information, then you're going to be receiving an outdated answer with a pretty high confidence. And it might even source, where it came from, in which gives you confidence that it's correct, but it might not be.
So the hardest part of RAG is the R. Is that what we can conclude?
I think so.
Yeah.
Or the most important part, yeah.
Maybe most important part, yeah. Ben, were you about to ask? Did I cut you off? Or you were going to add something to that?
Yeah, I was just going to say that it's more than, the retrieval part is potentially a lot more than just like getting the embedding model, right? Because there are a lot of different things that you could do to sort of prepare, the kind of getting into like what Justin was talking about as far as like how you do the chunking. I would consider that to be part of the retrieval. Even like what you end up putting into the context could be part of this. So there are different techniques like this that kind of multiply the number of different things you could try. So something that people do is use LLMs to summarize the documents, and then you could either calculate embeddings on those summaries and search over summaries, or you could summarize the documents that you retrieve and put summaries into the context. So I think there's a lot of different ways that you could do retrieval and potentially try to get sort of a more meaningful set of retrieved information to give to the generative LLM, more than just, oh, am I using the right embedding model?
Interesting. Okay, so the different, looks like this is a pretty simple diagram, but when you look at all the different ways to implement this, it can be quite different and quite complicated. All right, well, let's get to I guess it is the challenge in so many of these type of applications. But what makes RAG applications challenging to evaluate? It's like, we get asked this a lot of time before we start a project for a client, like, well, how are you going to tell us that it works? How are we going to know that it works? Just a perfectly reasonable question. So what are the challenges and ways you can evaluate a RAG application?
I think I have an analogy, so let's see if this works. It's kind of like giving an assignment to a student, say, write an essay on topic X. And then how do you evaluate? Well, that can be tricky because you have to look at the quality of the response. I mean, did they use the right grammar? Maybe that's the easy part, but how thorough was the response? Or was it too long-winded? So there's a lot, or, is the response, this essay, factually correct? And so there's different aspects of evaluation for RAG applications. So we could say, is it faithful or is it accurate? There's a metric called faithfulness, saying, does this generate a response? Is it supported by the evidence that was given, or did it hallucinate, which is often a problem?
So faithfulness is a measure of, inverse measure of hallucinations.
Yeah,
I feel like there's entropy in here somewhere. I don't know where. It's like it feels like there's some thermodynamic analogy here.
It's kind of distinct from whether you get the correct answer, right? So you could have a system that you're evaluating on just, is it answering this question correctly?
Right.
But faithfulness would show whether it was answering that question correctly based on information that it actually got in its context.
I see.
Like, say if you're using something like, say, GPT-4 as the generative LLM, at the end, GPT-4 knows about a lot of things. To go back to this, when Justin was talking about policies and things like that, GPT-4 is aware of a lot of public information. So you could be asking it questions about these documents that you're retrieving, and it just might know the answers,
right?
Even if you're not retrieving the right documents. So that's kind of what faithfulness does, is it looks at, what can you derive from the question and answer, and then what is in the context, and tries to make sure that they're related.
Yeah.
Okay. And then, I guess I imagine that this sounds like an entire area of research in terms of techniques to be able to do this, because there's no, I think people are looking for an area under the curve, how many false positives and false negatives, and that doesn't. I've seen nothing in any of this work that even comes close to that kind of simplistic.
It's difficult because unless you're doing something, and this is actually the way a lot of LLM evaluations work, is they're actually like multiple choice questions. So the LLM will actually output like A, B, C, or D. So it's very easy to check whether it got the right answer. A lot of these evaluations are not straightforward and actually require LLMs to do the evaluation. So how faithfulness works is you, given that sort of tuple of question and answer and context, you make prompts for another LLM and ask it to like generate statements and then evaluate statements. So it requires something that has that kind of reasoning power to be able to evaluate.
Yeah, I guess one of the criticisms I've seen of some of these multiple choice answers is you're putting the answer in the prompt itself. So you're kind of leading it down the, you're asking it to choose which of these four is wrong is a lot different than like find the right one in this pile of 5,000, right? Those are very different cognitive tasks.
Which I think that's another aspect that makes RAG applications difficult to evaluate is how easy or difficult are the input prompts or the input queries. So if I'm evaluating and I'm always asking it easy questions, so that's easy to get the right documents and generate a response. But then when it goes to users, they ask questions in a different way, or they ask questions using different vocabulary, or they just ask harder questions. Then they're going to see very different results that maybe I didn't plan for. And so there's this other sort of input variable of how easy or hard are the input questions, and how does that affect the retrieval and then the generation steps?
Yeah, this is such a great discussion, because I think then you also have this collision with reality where you can have like an academic, sort of evaluation metrics, very formal thinking. But with a practical application, a lot of times you can overcome this. You sit down, it's like, hey guys, here's the new application. When you write a question, write it like this. Like if you can knock out some of the worst stuff with a 2-minute conversation with the user, you don't have to invest 6 months of engineering work, or even just have the LLM. I think, Justin, in some of our episodes, you built like that reasonableness check out at the beginning. I think there's one I even asked I think it was episode 4 when I asked say it's like, hey, can Charlie open a checking account or something like that, right? And the reasonableness check comes back and says Charlie appears to be a pet, and Charlie cannot, but. I mean, there's like one question, one call the LLM, and you can imagine that being a way to constrain the trajectory of the application that takes the pressure off of such a high level of performance that requires an evaluation. I mean, it starts. Also, the more we get into this thing, it's just how do you ensure like intelligent systems are functioning correctly, like people, departments, team. I mean, it's like this, it's ambiguous. Like, how do you know your product team's working well? Well, we've got ways to do that. It's not the area under the curve. Yeah. And we could do an entire episode on this, but any other comments people want to make on like evaluation? All right. Well, then I will jump into the final question we have, which is, what are some techniques that can improve the performance of RAG?
This is still a big open question. I think a lot of people are still trying to figure this out. And I think why it's such a big question is depending on what kind of documents you're looking at, depending on what the domain is, whether it's sports or finance or pets, different techniques may work better or less well. And so I think, as we talked about earlier, one is just better search, which is really generic, but how do you get your retrieval better? Is it just using embeddings, or do you need embeddings plus metadata, or embeddings plus rules or heuristics? Anything you can do to get better retrieval is going to give you better results. That's one thing that we mentioned already that's top of mind.
Great points. Anyone have anything else to add to that?
Yeah, one area that I find interesting is in the retrieval step, just the summarization part. I think the majority of documents or things out there just generally have a lot of fluff to make things, easy and like enjoyable to read. But for an LLM, like looking for an answer, all of that isn't needed. And because we have these context size limitations, getting these summaries for the retrieval part, I think is like an interesting area to go down and it can make it faster to find the right documents that you're looking for.
Yeah.
Great.
Using summaries can definitely help. Something else that I found just very recently that also works is whenever I enter a query to a RAG system, have the LLM rephrase that a couple of times or generate several similar but different queries using different words, that is. And that just expands the efficacy of the retrieval step typically.
So instead of just a general cosine similarity score between the embeddings, you're saying, or I mean, is that so? I'm just back to our. Maybe I should point at the
No,
diagram.
I'm talking about just the text. So up there in the query.
Oh, I see.
What are this company's pet policies, and then have an LLM just right there before it does anything else. Rephrase that a couple of times. So, what are Prolego's policies regarding animals at work? What are the company's policies regarding, I don't know how many different ways you can say that, mammals and reptiles?
Right. Right.
Just using different vocabulary so that the retrieval step, the query embedding, is more likely to pick up relevant things.
Yeah. So that's in a pet policy, maybe not as relevant, but you're talking about a compliance regulatory law enforcement scenario where you could have lots of different rules and laws covering many edge cases, case law, misdemeanors, felonies, pick your poison. And you could just, what's the crime? I'm going to come up with silly examples, but what's the penalty for stealing something, or something like that. It's like, either tells, well, I guess in that case you could ask the user to be more specific, but I mean, generating 5 or 6 versions is going to do it broad the search, because people may think differently about a particular type of question.
Yeah.
Wow. Yes.
The more ways you can phrase that up front, or at least cover different rephrasings and vocabulary kind of synonyms, it'll often help.
Excellent. All right. And final comments or questions, guys, before we wrap things up?
Yeah, I just had a couple of comments about how maybe things could be improved. So something else you could do is, you can fine tune different parts of the system for your particular application. So fine tuning the embedding model is something that people do, or fine tuning an adapter, which is kind of like another model that you would put in between your query embedding and that cosine similarity. So that the idea with that model would be that it's sort of trying to make a better match for your particular application than what the embedding model would have in it.
So between this, like between these, like right here, basically. That's
Yeah.
where we go. Okay.
Yeah. And I know Justin's tried this with sort of mixed results, so it might not work for every case, but it's something that people are talking about. So I wanted to bring it up. And then just one comment too on Cam's comment about summarization. I believe it's from Salesforce. They put out a paper that shows a specific technique for prompting LLMs to do summarization, where it kind of iteratively coalesces something down into a smaller and smaller number of sentences. So there are specific techniques that you could try to get better summarizations out of the same model, basically.
Okay.
Just to summarize this text might not work as well as a longer prompt that gives more specific directions about how to summarize. So that might be worth experimenting with as well.
The interesting thing about that summarization technique is it aims to keep the most relevant named entities within the text as possible, and also telling the model to limit it to a certain number of words and sentences.
So it's like I'm going to be pulling some bit of information theory here, but it's like you're retaining the most valuable parts of it. The signal to noise ratio is just higher at that point. All right. Well, guys, thank you so much. This was a fantastic discussion. I learn a ton every time we talk, and just watching you guys work, because you're masters of the craft, is I learn a ton. It is humbling, I will admit it at times, because I sometimes like to think of myself as an expert in this stuff, and I realize how little I know when we get into a discussion like this. But it is a really joy and pleasure to work with all you and have these kind of discussions. Thank you so much. Have a fantastic day, everybody. I hope this was useful.